This problem, we're asked to find all the missing sides and angles of this rhombus behind me. And when it comes to finding all the missing sides and angles of something, you always want to remember what shape are you working with. In this case, a rhombus, we have to use properties like all the diagonals are going to cross at a 90-degree angle. So you can actually throw that in right now. Say these are all 90. You can either do it with the box or put a 90-degree symbol right here. You can do other things that know, like this, a rhombus is a parallelogram. So the opposite sides, or excuse me, opposite angles are going to be the same. The opposite sides are also going to be the same size. The diagonals bisect each other. So there's a bunch of things, a bunch of properties of rhombuses that you can use when it comes to finding these missing sides. Now, this also gives us a few different givens. The first one is that the measure of angle UTS, it says this is 31 degrees. I'm going to do all my angles, and let's go pink since I started with this one. So this is going to be 31. And one of the other properties of rhombi, that's probably the most prominent property, is that the angles are bisected. So if this is 31, so is this. This is also 31. And that means I can get the whole thing to be 62 here. And if that's true on this side, that's also going to be true on the top. This is 31, 31, and 62. I'll put that on the outside here, 62 degrees for all of it. Okay, I can do a little math as well. If I take 90 and 31, and I add those up and then subtract from 180, I'm gonna be left with 59 degrees for the other angle. And just like before, that's the same math in each one of these four triangles. And so this is also gonna be 59, and this is 59 and 59 over here as well. What is 59 plus 59? Well, 50 plus 50 is 100, and then 9 is 9 and 18. So we can put 118 degrees for each side. And if I were to add up all four, of course, that would equal 360 degrees. Okay, so I think we have all of our angles taken care of. Again, rhombi are nice because they have the 90s in the middle, and then the other ones are also easy to find. However, it only gives me one other measure here, and that's going to be that UT is 40. So let's mark that up. UT, always mark up your picture. It says is 40. And just like before, kind of like the opposite sides thing, the other part of this diagonal is also going to be 40. All right, so that means I'm just missing these two parts as well as each side. And one thing we know about a rhombus is that all the sides are going to be the same. So once I find one, I'll know them all, and I just would have to find the other one as well. How am I going to do that? It doesn't give me any other measures. I can't really use the Pythagorean theorem yet because I just know one part of these right triangles, but I can use trig. So you might want to grab a calculator if you have that handy. And let's take a look at, maybe I'm going to highlight this bottom right triangle here. And we're going to use this triangle as our triangle, kind of like we had in our trig unit, using sine, cosine, and tangent. And let's say this is 31 and this is 40. And let's say I want to find this top part first. All right, I'm going to call this x. Compared to my 31 degrees, I have the opposite. I have information along the opposite and the adjacent. So that's going to be tangent. Remember our word SOHCAHTOA? That's the TOA, the opposite and adjacent there. And so this is going to be tangent of 31. And that's going to equal the opposite x over the adjacent 40. And of course, to get x by itself here, I'd have to multiply both sides by 40. And that's going to be 40 tangent of 31. 40 times tangent of 31. And that's going to equal my x. So you might need to bust out your calculator. What is 40 times tangent of 31? That is 24.03. I'm just going to call it 24. I think it's safe to round to one decimal point there, 24.0 or 24. And so I can plug that in. And again, I'm using black for the side lengths. So I'll say this is 24. And that means the other side's also going to be 24 like that. Okay, then when it comes to finding the other parts, you could use the Pythagorean theorem now and just use your a squared plus your b squared to get your c squared. 24 squared plus 40 squared is going to equal to c squared here. That's going to be the same for all four sides. Or since we're using trig, I'll just use, to find this side right here, I'll just use trig again. This time maybe I'll call it y. And compared to my 31, I have I'm going to use this one since it's not rounded, the 40, and I would have the adjacent and the hypotenuse. And so for that, I would say that is cosine. Cosine of 31 equals the adjacent 40 over, this time my variable's on the bottom. So we always multiply by that bottom, just like we did here. Multiply by y this time. But then I also, since they cancel, I'd also have to divide by cosine of 31, just like this. And that's going to cancel on this side, leave me with 40 divided by cosine of my 31, kind of got cut off there. So what is 40 divided by cosine of 31? And that is 46.66. So if I round it up, I'm going to say this is 46.7. 46.7. So again, this is rounded just a little bit, 46.7. And that means that all the sides, since this is a rhombus, are also going to be 46.7. 46.7. All right, so if you wanted to, you could figure out the perimeter. Now, you might want to leave this number unrounded in your calculator and then take it times 4 to find the perimeter. Let's see the difference here. If I take that number, that's, so I haven't rounded it yet in my calculator. If I take that times 4, that's going to be 186.66. 186.7 as opposed to, I'll round it a little bit, as opposed to 46.7. 6.7 times 4, that's 160 or 186, excuse me, 0.8. So a difference of 0.1. I doubt your teacher would probably get too upset about that. If they want, though, and if they want a more specific answer for like your perimeter, you might want to wait to round that number until you are done at the end. Okay, otherwise, I think we found all of our missing angles, all of our missing sides, as well as the diagonals. And so therefore, we found everything we needed to in this rhombus. Hopefully this video helped you out, and until the next one, keep doing your math homework fast and accurately.